Down here it says math tip. Angles can be classified by their measures. So that's what we were talking about earlier. It said give different characteristics. Well, that's what we did. An acute angle measures greater than 0 degrees and less than 90. A right angle is 90. An obtuse angle measures greater than 90 and less than 180. And a straight angle is 180 degrees. So there are those 4 different angles once again that we've already talked about in item 1 at the very beginning. Okay, item 4. It says complete the chart by naming all the listed angle types in each figure. And so we've got this diagram, or this chart. We have 2 columns. One column is for the first diagram over here, which is extremely similar to the one we just got done talking about. And then the second column to the right is talking about this second diagram. A little bit more intense, a little bit more things going on, but I hope that I can show you they're not that different. So here we go. I've already filled this out just to save time on the video. But the first column, we're referring to this first diagram. It says acute angles. The acute angles, or the angles that appear to be acute, are angle 8 and angle 9. Notice how I'm talking about the objects. I'm talking about the objects. I'm saying, hey, this is acute. I'm not saying anything about its measure yet. I know that if I have an acute angle that its measure is greater than 0 and less than 90, but they're just asking us to identify acute angles. And so you would not put the M in front of it. You would just say, hey, angle 8 is acute. Angle 9 is acute. Next one, obtuse angles. That would be angle 10 and angle 7. Those 2 angles are obtuse. The next one is the angles with the same measure. So now that we moved into measurements of these angles, I'm going to say that the measurement of angle 8 is equal to the measurement of angle 9. Those are those vertical angles, and the measurement of angle 10 is equal to the measurement of angle 7. Those are your 2 pairs of vertical angles. The next one is supplementary angles. And so what I wrote was the supplementary angles in this diagram are all 4 linear pair. It's all 4 linear pair. So you have 8 and 7. That's 1 linear pair. You have 7 and 9. That's a linear pair. You have 9 and 10. 9 and 10, that's a linear pair. And then you have 10 and 8. 10 and 8 are linear pair. So you have 4 linear pair when those 2 lines intersect. The last one is complementary angles. There's none. There's none in this diagram, this first diagram. Cool. So moving on to the next diagram. I hope that everyone can see that these 2 diagrams are not that different. First off, you have 2 lines that are intersecting. You have this line, and you have this line. Those 2 lines intersect at point B. Well, that diagram is exactly like this one up here that we just talked about, and it's exactly like this one up here that we talked about. You're going to have 4 sets of linear pair. You're going to have 2 sets of vertical angles. The only thing that's different is in this diagram, they added a ray that's coming from the point of intersection, point B, and it's leaving, or it's protruding from that line at a 90-degree angle. So what is in orange ink is the only thing that's different from this diagram and that diagram. So the reason I bring that up is because we're going to have a lot of very similar answers. What happened over here with the acute angles is going to happen over here with for this diagram as well. And you're going to have obtuse angles, but then you just got to accommodate and include the angles that are being formed by this one ray that's different. So here we go, the acute angles. You have these 2 here. These are your 2 angles being formed by those intersecting lines. Those are also vertical angles. They're congruent. They have the same measure. But when we add in this ray, you also have this one, angle CBD. So you have 3 angles there, angle ABF, angle DBE, and then angle CBD. Obtuse angles, you have your 2 obtuse that were formed by your two intersecting lines. So those would be angles ABD and FBE. But when you introduce this ray here, you also have a third obtuse angle, which is angle CBF. The next one, the angles with the same measure. You have your vertical angles. So your two acute vertical angles, ABF and DBE. You also have your two obtuse vertical angles. So you have ABD and FBE. But now you also have another set of congruent angles, or two angles that have the same measure. And that would be your two 90-degree angles. You have angle ABC, which is 90 degrees, and you have angle CBE. Now I understand that there is not a box here that indicates it's a 90-degree angle, but that's okay, because this is one of those times where we can deduce that this angle is 90 degrees. We have a linear pair here that forms this straight line. So if this angle is 90 degrees, because it has that marking in it, well, 90 plus what is going to equal the 180 degrees? Well, it has to be 90 degrees. So this is one of those times where it doesn't have the box, but we're not assuming it's 90 degrees. We know it's 90 degrees because we're using our knowledge of linear pair and supplementary angles. So we're not assuming. We can prove to ourselves, or more importantly, you can prove to me that you know this is 90 degrees. So that's not making an assumption. We can prove using our deductive reasoning. So there you go. Those are your four. I'm sorry. Those are your three pairs of angles that have the same measure. You have your vertical angles and your two 90-degree angles. And so these are my two 90-degree angles off here. I ran out of room. The next one is supplementary angles. You have your four linear pair, just like this diagram. You have your four linear pair. So you have these two, obtuse and acute. Then you have these two, acute and obtuse. Then you got these two. Just notice I'm just going around this diagram. So these two that are a linear pair, they're supplementary. And then these two, you're obtuse and acute. So not only do you have those four linear pair, but you also have the pair of 90-degree angles that are supplementary. So you have 5 total. When it comes to complementary angles, I hope that you remember that complementary angles are angles that sum up to be 90 degrees. So I hope everyone sees that these two angles are complementary. Angle CBD is complementary to angle DBE. Those two added to be 90 degrees. But also, there's one more pair. Since this angle here has the same measure as angle ABF, well, if this angle is the same as this angle, so these two angles have the same measure, then, well, this angle plus that angle equals 90 degrees, then that angle plus this angle, these two, must add up to be 90 degrees as well. Complementary angles don't have to be adjacent. They don't have to be right next to each other. They don't have to have a common vertex. They just need to sum up to be 90 degrees. So that's why the last one, angle CBD and angle ABF, those two angles are complementary angles. Moving on. This is page 9. Still dealing with lesson 1-2, still in activity 1. We're going to get into circles now. It gives us 3 definitions right off the bat. So highlight these, star these, circle them, do whatever. You got to draw attention to these 3 definitions. I know that you've dealt with circles before, and I know that you have an understanding of what diameters and radii are, but you need to know the pre-AP geometric definition of these geometric figures. So first off, they start with a chord. A chord of a circle is a segment. Stop there. This is a geometric figure. This is a piece This is a part of a line that has two endpoints. There's a clear beginning and a clear end. So we know that the chord, it is a geometric figure. It's a segment. It has a clear beginning, clear end. There's two endpoints. So a chord of a circle is a segment with both endpoints on the circle. So wherever that segment is, as long as its endpoints are somewhere on the circle. And what I mean by on the circle, I mean on this locus of points, this curved line that's going around. This is the circle. It's not in, we're not talking about the inside, we're not talking about outside. If endpoints are on the circle, that means it's on this curve, it's on this locus. So going on to the next one. A diameter, so a new term, a diameter is a chord, so let's stop right there. It's a chord that, and then it's a special chord. But if we were to write this definition out or expand this definition, I would say a diameter is a segment with both endpoints on the circle that passes through the center of the circle. So please recognize that a diameter is a chord. It's just a special chord. It contains the center of the circle. It goes through the center of the circle. The next new term is a radius. It too is a segment, just like a chord, just like a diameter. It is a segment. That's the geometric figure that it is. But these two endpoints are in different places. When you're dealing with a radius, one of the endpoints is on the circle, but the other one is the center of the circle. So let's practice this and draw these. Item 5A, it says draw radius OA. Well, if you look, we're also going to have to draw chord BA and diameter CA. Since I know that when you're dealing with chords and diameters, those two endpoints have to be on the circle. Well, if point A is one of the endpoints of a chord, that means it's going to have to be on the circle somewhere. So when I draw radius OA, I have to make sure that endpoint A is out on the circle, making the center point O. Because you can't have 2 point A's in one diagram. So there's my radius. It's a segment, 2 endpoints, O and A. Now I'm going to draw a chord BA. Well, I already have drawn point A on this diagram, so I can't make up a new one, so I must incorporate this. So I just need to find another point on the circle, and that would be chord BA. So I'm just going to go across this way, and this is be point B. So now I have segment BA. Since this segment has its two endpoints on the circle, that means it is a chord. You could have gone down here and said, hey, point B, and done that. That would have been fine. I just chose to go to the top left. And then diameter CA. Well, again, A is one of its endpoints. I know that a diameter is a chord, so the other endpoint must be on the circle, but it has to contain this center. So it must go through the center and keep traveling and going to the other side. And so this would be point C here. So I have diameter CA. I'll try to do some colors. This is that one in green. We'll do that. So that's that one. And then the whole thing in blue, that diameter, that's that one. So there are your 3 segments in that diagram. And again, make sure you don't have multiple point A's in one diagram. That just doesn't make sense. Item 6 says, refer to your drawings in the circle above. What is the geometric term for point O? That is your center. The center of the circle.